What is the purpose of Spanning Tree Protocol, STP? The purpose of Spanning Tree Protocol, STP, is to prevent loops in a switched Ethernet network. Disable alternate paths. By doing this, it ensures that there is only one active path at a time between two network devices, thus preventing loops and the broadcast radiation that results from them. STP also provides a way for switches to share information and automatically reconfigure the network topology to prevent loops. It allows for redundant paths while preventing loops, which can increase network availability and reliability. How does STP prevent network loops? The STP algorithm uses a set of rules to determine the root bridge, which is the central point of the spanning tree. The root bridge is the switch with the lowest bridge ID, and all other switches in the network will connect to it. The algorithm then assigns a cost to each link based on its bandwidth, and the path with the lowest cost is selected as the active path. Once the spanning tree is established, all switches in the network will send and receive Bridge Protocol Data Units, BPDUs, to keep track of the topology changes. If a loop is detected, the switch will immediately disable the port that is causing the loop to prevent data from being forwarded in a loop. 3. There are several different versions of Spanning Tree Protocol, STP, including IEEE 802.1d. This is the original STP standard, also known as Standard STP, or Common Spanning Tree, CST. It was designed for preventing loops in a switched Ethernet network, but it had slower convergence time. IEEE 802.1w, also known as Rapid Spanning Tree Protocol, RSTP, it was introduced to speed up the convergence time of the STP algorithm. It introduced new port states and new BPDU, Bridge Protocol Data Unit, format to quickly transition to the forwarding state. IEEE 802.1s, also known as Multiple Spanning Tree Protocol, MSTP, it allows for multiple spanning tree instances to coexist within a single network. It allows for creating multiple VLANs and assign them to different spanning tree instances. IEEE 802.1q, also called Provider Bridges, PBST, which is an extension of IEEE 802.1d and IEEE 802.1s that allows the creation of multiple spanning tree instances across VLANs. IEEE 802.1q 2018. This is the latest version of STP, also known as Rapid Spanning Tree Protocol, RSTP+. It is an update to IEEE 802.1q that provides faster convergence and enhanced security features. 4. Spanning Tree Protocol, STP, uses several different port states to ensure that there is only one active path between two network devices at a time and to prevent loops. The main port states are blocking. This is the initial state of a port when STP is first enabled. The port does not forward any data, but it does receive and process Bridge Protocol Data Units, BPDUs, to learn about the network topology. Listening. After a period of time in the blocking state, the port will transition to the listening state. In this state, the port is still not forwarding any data, but it is preparing to do so. The port sends and receives BPDUs to ensure that no loops have formed while it was in the blocking state. Learning. After a period of time in the listening state, the port will transition to the learning state. In this state, the port begins to learn the MAC addresses of devices that are connected to it, but it still does not forward any data. The port continues to send and receive BPDUs to ensure that no loops have formed. Forwarding. After a period of time in the learning state, the port will transition to the forwarding state. In this state, the port can forward data and participate in the active topology of the network. The port continues to send and receive BPDUs to detect any topology changes.